Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to present the problems on solenoidal and irrotational vectors in vector differentiation. So now see the problems related to this. So how to prove a vector is a solenoidal vector and how to prove a vector is an irrotational vector. Suppose if del is the differential operator, del means differential operator means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, and it can be applied on both the scalar functions as well as vector functions. So if you applied del on f bar as a dot product, then it is called divergence of f bar. If you apply del means differential operator, f bar is any vector point function. If you apply the operator del on f bar as a dot product, then it is del dot f bar and we call it as divergence of f bar. Already we have seen in the previous lessons. Similarly, if you apply del on f bar as a cross product, then it is del cross f bar, that is curly f bar. Curly f bar means del cross f bar, div f bar means curly div f bar means del dot f bar, and curly f bar means it is del cross f bar. Suppose if div f bar is equal to 0, div f bar is always a scalar. The dot product of two vectors always a scalar. The cross product of two vectors is always a vector. If div f bar is equal to 0, which is a real number, constant or scalar quantity, then it is called solenoidal vector. The vector f bar is said to be solenoidal vector. If div f bar is equal to 0, then the vector f bar is said to be solenoidal vector. If curly f bar is equal to 0 bar, then f bar is said to be irrotational vector. If f bar is an irrotational vector, then curly f bar is equal to 0 bar, because the curly f bar is always a vector quantity. Curly f bar is equal to 0 bar, then the vector f bar is said to be irrotational vector. That means what to do that? The vector, to show that the vector is a solenoidal vector, we have to consider div f bar, and if it is 0, it is solenoidal vector. Similarly, we consider the curly f bar. If del cross f bar is equal to 0 bar, then the vector is an irrotational vector. Now, I want to do this problem. Prove that the vector y square minus z square plus 3yz minus 2x into I bar plus 3xz plus 2xy into j bar plus 3xy minus 2xz plus 2z into k bar is both solenoidal and irrotational vector. Now I take this problem, y square minus z square, the given vector f bar is equal to y square minus z square plus 3yz minus 2x into I bar. That is the first I bar coefficient. 3xz plus 2xy into j bar plus 3xy minus 2xz plus 2z into k bar. So this is the given vector. Now to show that f bar is solenoidal, so consider del dot f bar, that we call it as divergence of f bar. So del means what? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with the vector y square minus z square plus 3yz minus 2x into I bar plus 3xz plus 2xy into j bar plus 3xy minus 2xz plus 2z into k bar. So how you can find I bar dot I bar 1? So dou by dou x of the entire term. Dou by dou x of that entire term is minus 2 only. partial derivative with respect to x. It is y term 0 derivative, z term derivative also 0. 3yz, 3 constant, y constant, z constant, because we are differentiating partially with respect to x. Minus 2x will be the value, that is minus 2, plus j bar dot j bar 1, j bar dot I bar 0, j bar dot k bar 0. Only will get the value of j bar dot j bar. Dou by dou y of entire thing. Dou by dou y of the entire thing is 2x only. Dou by dou y of entire thing is 2x only. Next, dou by dou z of entire thing. Dou by dou z. This is, here dou by dou z of this one 0 and minus 2x and plus 2. Dou by dou z of this one. This term is 0. With respect to z means minus 2x already here entered. Dou by dou z of 2z, that is 2. So clearly it is minus 2 plus 2 gets cancelled. Plus 2x minus 2x gets cancelled. This value is equal to 0. So div f bar 0 means f bar is solenoidal vector. That is the first solution. Div f bar is equal to 0. So the vector f bar is said to be solenoidal vector. Similarly, we have to prove the vector f bar is irrotational also. So irrotational means how to do? We consider curly f bar, and if it is 0 bar, then the vector f bar is said to be irrotational vector. For that, to show that irrotational. So to show that irrotational means consider curly f bar, that is del cross f bar, that is determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. The last row, y square minus z square plus 3yz minus 2x. Similarly, j bar coefficient, 3xz plus 2xy. This k bar coefficient, 3xy minus 2xz plus 2z. So what is the value I bar into? So see this I bar into what is dou by dou y of this one. Dou by of dou y is 3x. This is 0, only plus 3x minus dou by dou z of this one. Dou by dou z of this one, this is 0, this is 3x only. Minus j bar into. So you know how to find the determinant of the matrix. So minus j bar into, discard this column and this row, dou by dou x of this one, that is 3y minus 2z minus dou by dou z of this one. Dou by dou z of this one is minus of minus plus 2z. This is 0. Z square derivative 2z, already minus sign, it will minus sign. So this is plus 2z. Then 3yz, that will give minus 3y, and this is 0. Plus k bar into last one. On discarding the last column and first row. First row and last column, k bar, dou by dou x of this one, that is 3z plus 2y minus here dou by dou y, that means it is 2y. This is y square derivative 2y, z square derivative 0, 3yz derivative minus 3z, and this is 0. So what you will get? 3x minus 3x, 0 into I bar 0 bar minus these two gets cancelled, 0 bar, and here also these are cancelled, that is 0 bar. So this is equal to 0 bar. So curly f bar is equal to 0 bar. So the vector f bar is said to be irrotational vector. Very simple. Just we have to find curly f bar. If it is 0 bar, then the vector is irrotational vector. If div f bar 0 bar 0, then the vector is said to be solenoidal vector. And we will see some more problems on the del operation del. If r bar is equal to xi bar plus yj bar plus zk bar, then show that grad r power n is equal to n into r power n minus 2 into r bar. So given that, what is given that r bar is equal to xi bar plus yj bar plus zk bar. When r bar is this one, then r is defined as magnitude of r bar, that is root of x square plus y square plus z square. R means it is a scalar. R bar is vector. R is a scalar which is defined as magnitude of r bar, that is root of x square plus y square plus z square. Then dou r by dou x. Dou r by dou x means the partial derivative of r with respect to x. So root of this one derivative 1 by 2 root of x square plus y square plus z square into, with respect to x means you will get 2x also. Y square term 0, z square term 0. So 2 to cancel, and root x square plus y square plus z square can be replaced by r. So this is x by r. Throughout this problem, dou r by dou x is treated as x by r. Similarly, dou r by dou y. Dou r by dou y is same thing, 1 by 2 root of x square plus y square plus z square into 2y, or this is equal to y by r. Similarly, dou r by dou z, that is z by r. Dou r by dou z is z by r. So now I want to consider grad r power n. So grad means what? Del I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of r power n. So this entire thing I can write it as sigma I bar dou by dou x of r power n. The summation I bar into dou by dou x of r power n is n into r power n minus 1 into dou r by dou x. R power n derivative n into r power n minus 1 into, with respect to x means you will get dou r by dou x factor also. That is summation I bar into n into r power n minus 1 into dou r by dou x means x by r. Dou r by dou x is replaced by x by r. So here what I can write it is summation I bar into n into r power n minus 2 into x. Or I can take out this value n into, I can write n into r power n minus 2 is outside, summation xi bar. N into r power n minus 2, it is constant. So here we will get in similar terms y and z. So x is a variable, n into r power n minus 2 constant, and taking outside n into r power n minus 2 into xi bar. What is sigma xi bar? What is sigma xi bar? That is xi bar plus yj bar plus zk bar. That is n into r power n minus 2 into, this whole thing is r bar, that is grad r power n. So grad r power n can be written as, can be proved as n into r power n minus 2 into r bar. Grad r power n into r power n minus 2 into r bar. This is the proof. Now see the next problem. Calculate del square f. When f is given as a scalar function 3x square z minus y square z cube plus 4x cube y plus 2x minus 3y minus 5 at the point 1 comma 1 comma 0. So what is del square? First I want to define del square. Del square is called Laplacian operator, which is meaning that del dot del. So del dot del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of some function. So I bar dot I bar 1 dou by dou x of dou by dou x, dou square by dou x square. J bar dot j bar 1 dou by dou y of dou by dou y, that is dou square by dou y square. The last one dou square by dou z square. This is called the Laplacian operator. Wherever you find del square, you write del square is instead of del square, you can write dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Now consider del square f, that is dou square by dou x square plus dou square by dou y square plus dou square by dou z square of the function 3x square z minus y square z cube plus 4x cube y plus 2x minus 3y minus 5. So before that, call this is equation 1. I substitute the separately. Now, dou square by dou x square, dou square by dou x square of f, that is dou by dou x of f. That means what? Dou by dou x of, so on derivative, on taking differentiation with respect to x, 3x square z, that is 6xz, only we have to consider x terms, yz are treated as constant, this is 0, and 4x cube y, that is plus 12x square y, and plus 2x plus 2, this is 0, this is 0. So and again differentiating with respect to x, 6z, that is 6z, plus x square derivative 2x, 24xy, 6z plus 24xy, that is the dou square by dou x square of f. Then dou square by dou x square of f at the point, what is the given point? 1, 1, 0. What is the value? 1, 1, 0. x1, y1, z0. So first term 0, 24, 0 plus 24 into x into y, that is equal to 24. This is the first value. Similarly, dou square by dou y square of f, that means what? Dou by dou y of dou f by dou y. So what is dou f by dou y? Here on seeing dou by dou y of f, first term 0, and no y term, this is 0, this is 0. Only 3 terms will get, minus 2yz cube, dou by dou y of minus 2yz cube, that is the first term, minus 2yz cube. Here, y1 means 4x cube, plus 4x cube. Next, this is 0, minus 3. It is minus 3. Then again on differentiating with respect to y, minus 2z cube plus 0 plus 0. That is minus 2 into, therefore, dou square by dou y square of f at point 1, 1, 0 is equal to 0. This is the second value. Similarly, dou square f by dou z square, that is dou by dou z of dou f by dou z. That is dou by dou z. What is dou f by dou z? Dou f by dou z, this is f. With respect to z means what you will get? With respect to z you have to differentiate. These terms will get 0, this 0, this 0, this 0. Only 2 terms will get, because z is containing 3x square first term, 3x square minus, so with respect to z, 3x y square z square minus 3y square z square. And again differentiating with respect to z, this is 0, minus 3y square into 2z, that is minus 6y square z, minus 6y square z. Therefore, dou square f by dou z square at the point 1, 1, 0 is equal to, this is also 0, because z is there, z is 0, entire term is 0. Therefore, what is the value? Therefore, del square f at the point 1, 1, 0 is equal to, first value 24, second value 0, third value also 0, that is equal to 24 is the required solution. This is Laplacian operator. We call it as Laplacian operator, del square f. So with these 3 problems, I conclude this is just already, these models have been discussed in the previous videos. Just I want to see some basic problems in solenoidal and irrotational and del square. Del is the grad or del operator, how to operate on the scalar functions and how to operate the vector function. That is the main focus. So with these few words or few problems, I conclude my session in this. And you can have the more problems can be taken from question bank. So these problems have been taken from question bank of the course Differential Equations and Vector Calculus of BT 23 and published by IARE. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.